Supreetha. Welcome to my math class. In this session, let us learn how to find the general solution of linear differential equation with constant coefficients. Yes, now before we start on how to solve these type of problems, let us learn two important keywords, that is order and degree of a differential equation, which we have already studied. Right? Say for example, I have y double dash plus y is equal to 0. The highest derivative over here is 2, right? So they've differentiated the equation twice. So the order of the equation, the order of the differential equation would be 2. And what is the power of this term? It is 1, right? So the degree is clearly 1. So whenever the degree is 1, we call it as the linear differential equation. Okay, and say for example, I have another equation, y dash the whole square plus y is equal to sine x. Yes, so clearly the highest derivative is dy by dx, that is y dash. So the order over here would be 1 and the degree is clearly 2, right? Y dash square, so the degree would be 2. Okay. Now, moving on, let us start our topic, that is linear differential equation. Right, so let me write down a linear differential equation with highest order. Let me take, say for example, d power n by dx to the power n y plus, it decreases, right, dn minus 1 dx to the power n minus 1 y, so on up to, say for example, I have dy by dx plus y is equal to x, where x is a function of x. Okay, and what else does the heading say? It says linear differential equation with constant coefficients. So let me write down constants, right? A naught, a1, here let me write down an minus 1, an is equal to x. Right, so clearly let me write down saying that a naught will not be equal to 0 because it's obvious, and a1, a2, so on up to an are all what? They are all constants. And what is x? X is a function of x, right? It can be sin x, cos x, or any function of x. Okay, now in these types of problems, we usually take a denotation, right? We write d by dx as capital D just for our convenience. Okay, instead of writing d by dx in all of the problems, we write it as capital D. Then d square by dx square would become what? It would become d square. So on up to dn by dx power n would become d to the power n. Okay, let me replace in the general form, right? What would happen to the general form over here? So we'll get a naught dn y plus a1 dn minus 1 y plus so on up to an minus 1 d y would be there, and y would remain as it is. This is equal to our x. Yes. Now clearly y is common in all of the terms. Let me take it out as common. So I would get a naught dn plus a1 dn minus 1 plus so on up to an minus 1 d plus an whole thing into y is equal to capital X. Yes, so what are we trying to learn over here? We are trying to learn how to find the general solution of this equation, right? The general solution of this equation, that is y, is always equal to complementary function. We shortly call it as CF. Okay, complementary function, or let me write it as CF plus particular integral that is pi. Okay, in short we usually write y is nothing but CF plus pi. Okay, and one more important definition over here is in this equation, in the general form what we have, let me name it as equation 1 over here. In equation 1, yes, in equation 1, if the RHS term x is equal to 0, we call it as a homogeneous differential equation. And if x is not equal to 0, we call it as non-homogeneous differential equations. Okay, so what did we study till now? We have studied about, we just wrote the general form of linear differential equation with constant coefficient, and one small substitution over here, that is d by dx is equal to capital D. We just replaced it, and we saw that the general solution of these type of equations would always be the sum of complementary function and particular integral. Now let us see how to find these complementary functions and particular integral step by step. Now to find the CF over here, yes, to find the complementary function in our general form, right, we replace d as m and the RHS part would be 0. That is, it becomes a homogeneous differential equation. Okay, so when we replace this, what happens to our general form? We call it as the auxiliary equation. Okay, auxiliary equation, or you can shortly write it as AE. Right, the auxiliary equation would be, we had A naught m to the power n plus A1 m to the power n minus 1 plus so on up to an is equal to 0. Let me name this as equation 2. Now to solve this equation 2 over here, this just comes down to our normal equations, right? We would get linear equation, quadratic equation, cubic equation and so on. Polynomial equation in short. Okay, to solve this, we will go back to our 8th standard math that we have already studied, finding the roots. Okay, splitting the middle term or finding the roots of the equation. Now, solving equation 2, let me write down, solving equation 2, how many roots will we get? The highest power over here, right? We get how many roots? We get n roots for the term m. Say for example, the roots are m1, m2 and so on up to mn. Now these roots can be of 3 types, right? Let me take 3 cases over here. Case 1, say for example, the roots are real and distinct. Say for example, we got 1, 2, 3 or 1, 2 which are not equal and they are different, right? So if m1, let me take 2 roots for now, m1 and m2 are real and distinct. Okay, so what happens then? The CF would be in the form C1, or you can also write it as A. Okay, it's just a constant, A e to the power m1x plus B e to the power m2x. If we had taken m1 to mn, okay, if we have mn different roots, you can write it as, if we had m1, m2 so on up to mn roots that are real and distinct, the CF would be A e to the power m1x plus B e to the power m2x plus so on up to, say for example, some letter C e to the power mnx. These are constants. We can write anything over there. Okay, so that was about case 1. Moving on to case 2, what happens? What if the roots are real and equal? Okay, what if the roots are real and equal. Say for example we have two roots and those are equal to m1 equals m2 equals m. Then the CF would become C1 plus C2x whole thing into e to the power mx. Okay, what if we have three roots, m1 equals m2 equals m3 equals say m. Then the CF would be C1 plus C2x plus C3x square whole thing into e to the power mx and so on. So we are done with two types, right? The first one was real and distinct, real and equal. What is the other possibility of getting a root? The other possibility would be, let me write it as case 3, that is if the roots are imaginary. Okay, say for example we have roots in the form of imaginary. What do you mean by imaginary? What comes to your mind when I say imaginary? Say for example we have I, right? Complex roots over here. Then what happens? We usually get it in the form of a plus ib. Agree? A plus ib, or in some of the books they would have mentioned it as alpha, beta, anything is fine. Then the CF would be of the form of e to the power ax, the real part, into C1 cos bx plus C2 sin bx. Okay, this would be our CF for imaginary roots. Yes, now let us solve a few problems based on these types, these cases. Let us try finding the complementary function. Let us take a homogeneous equation, right? Whenever the RHS is equal to 0, we get a homogeneous equation. So let me write down a homogeneous equation. Say for example they've asked you to solve d square minus 4d plus 4 is equal to 0. What happens? The first step, what was the first step? The first step says replace d as m. When you replace d as m, we would be getting the auxiliary equation, right? The auxiliary equation is m square minus 4m plus 4 is equal to 0. Now what is the second step? We'll have to find the values of m, right? So how do you find the values of m? Just use the basic math that we know. This looks in the form of a square minus 2ab plus b square, which is nothing but m minus 2 the whole square is equal to 0. So we have m minus 2 into m minus 2, equate each term to 0. We would be getting the roots as m is equal to 2, 2. So clearly over here, if you observe, the roots are real and equal, right? So when the roots are real and equal, the CF would be, let me write down, CF would be C1 plus C2x into e to the power 2x. As I told you, C1 and C2 are constants. You can either use C1, C2, A, B, anything other than x and y, because we are already using those in this problem. Okay. So, and one more thing. Since the given question is a homogeneous equation, we will have only CF over here. We can also call it as y. This is only our final solution. Okay, y is equal to C1 plus C2x into e to the power 2x. Yes, now moving on. Let us solve another problem over here. Okay, so the second problem says solve d square plus 3d plus 2 whole thing into y is equal to 0. Yes, so clearly how would you find the roots over here? First step says find the auxiliary equation, right? The auxiliary equation of the given question would be m square plus 3m plus 2 is equal to 0. Yes, so we know that 2, right? 2 ones are 2 and 2 plus 1 is 3. So the roots would be m plus 2 into m plus 1 is equal to 0. Equate each term to 0. M plus 2 is equal to 0. M plus 1 is equal to 0. Right. The same thing follows. M is equal to negative 2 and M is equal to negative 1. So clearly what happens to our CF over here? It would be C1 e to the power negative 2x plus C2 e to the power negative x. Okay, so as I told you, this only is our final equation, final solution of the given differential equation, because it is a homogeneous differential equation. So let us solve the third question, that is solve d square y by dx square plus y is equal to 0. So if we replace d square by dx square as d, we would be getting d square plus 1 whole thing into y is equal to 0. Right. So what would be our auxiliary equation over here? Auxiliary equation would be m square plus 1 is equal to 0. Clearly y is not equal to 0, right? That is what we are trying to find. So m square plus 1 has to be equal to 0. Okay, so what would m square be? It is negative 1. So what is m? M is nothing but plus or minus square root of negative 1. And we know that the square root of negative 1 is nothing but I. That is the complex term. Agree? So what was the CF for complex or imaginary terms? Whenever we have the root in the form of a plus or minus I into b, our CF would be e to the power ax, right, into a or c1, anything is fine, cos bx plus b sin bx. Okay, now clearly we don't have anything, the real term is 0, right? Over here this we can write as 0 plus or minus I, 1 into I, right? So the value of b is clearly 1 over here. So what happens to our CF, which is nothing but our final solution y, e to the power 0x, right? E to the power 0 is 1. So yeah, as I was saying, e to the power 0 would be 1 itself. So we would get the final answer as a cos 1, right? So 1 into x is nothing but 1 plus b sin x. Okay, so this is how we solve a linear differential equation of higher order, the constant coefficients. Now let me take another question over here, say the fourth question, right? Fourth question, it says solve, let us solve y double dash plus 4y dash plus 20y is equal to 0. Or we can also write it as d square plus 4d plus 20 whole thing into y is nothing but 0. Yes. Now what happens over here? The value of, let me write down the auxiliary equation, that is replace d as m. Okay, and we would be getting m square plus 4m plus 20. This is nothing but 0. Yes. Now how do we find the roots of this equation? Just multiply two terms, add or subtract to get 4. It's a bit confusing, right? So let us use the formula. We know a formula for quadratic equation of the form ax square plus bx plus c is equal to 0, right? So x is nothing but minus b plus or minus square root of b square minus 4ac by 2a. Agree. Let me write this properly over here. It would be 4ac. So what do we have in place of a, b and c? Just compare and substitute. We would get minus 4 plus or minus square root of 16 minus 4 into 1 into 20, 4 into 20, right, divided by 2 into a, that is 2 itself, because the value of a is 1 over here. Coefficient of m square is 1. Okay, so minus 4 plus or minus square root of 16 minus 80 divided by 2. So we would be getting minus 4 plus or minus square root of 4 and 8 minus 2 is 6, negative, right? And what is square root of negative 64? I can write this as minus 4 plus or minus, I can write 64 as 64 into 1, right? So it would be minus 1 into square root of 64, right, divided by 2. We know that square root of negative 1 is nothing but I, and square root of 64 is 8. 8 is 64. In the numerator we have 2 common, agree? So we'll get minus 2 plus or minus 4 is 8 divided by 2. These 2 gets cancelled. So we are left with negative 2 plus or minus 4i. So that is the value of our m over here. Okay, m is nothing but negative 2 plus or minus 4i. So what would our CF be? Our CF would be, which is nothing but our final solution, e to the power negative 2x into c1 cos 4x plus c2 sin 4x. Okay, the value of a was negative 2 and the value of b is 4 over here. That is how we have substituted, right? So let us solve another question based on the same concept. Yes, so fifth question says d cube, solve d cube plus 2d square plus d whole thing into y is equal to 0. So clearly the auxiliary equation over here would be m cube plus 2m square plus m is equal to 0. If you take out m is common, we would get m square plus 2m plus 1 is equal to 0, right? And m square plus 2m plus 1 looks like m plus 1 the whole square, right? A plus b the whole square formula. If you just compare it, we can write it like this. Now this is a cubic equation, so you have to get 3 roots, right? So what are the 3 roots? M is equal to 0 is one of the roots, and if you equate m plus 1 is equal to 0, we would get m is equal to negative 1. So these are the 3 roots of this cubic equation. So the roots are 0 is different from negative 1, but these two negative 1s are same. So I'll be writing it as a e power 0 into x plus b plus cx into e to the power negative x. Or I can also write it as, we know that e to the power 0 is 1, so a into 1 is 1 itself, plus b plus cx e to the power negative x. Okay, this is the final solution of the given differential equation. Okay, now moving on, let us solve another differential equation. They've asked us to solve d square minus 5d plus 6 whole thing into y is equal to 0. Simple question, agree? So if I write the auxiliary equation, it would be m square minus 5m plus 6 is equal to 0. I can just split 6 as 3 2s are 6. Yes, 3 plus 2 is 5 and the greater number sign has to be negative. So clearly we can write the roots as m minus 3, m minus 2 is equal to 0. equate each term, we would get m is equal to 3, 2. Or you can write the CF as what? We can write the CF, the complementary function or the final solution would be C1 e to the power 3x plus C2 e to the power 2x. This is our final solution. Okay. Now say for example we have another question that says solve d cube y by dx cube plus 2d square y by dx square minus dy by dx minus 2y is equal to 0. So what would our auxiliary equation be? Our auxiliary equation would be m cube plus 2m square minus m minus 2 is equal to 0. Now to solve this equation, firstly observe if you can solve this by inspection method. What is this inspection method? Just try taking common over here. We have m square common in the first two terms, so I would get m plus 2. Negative 1 is common over here. I have m plus 2. You can solve this, right? Clearly the bracket terms are same. Write it as it is. And the remaining terms, that is m square minus 1 is nothing but 0. Again, all these are school math, right? Basic maths. Now, equate each term to 0. We would get m plus 2 is equal to 0. M square minus 1 is equal to 0. So clearly m is nothing but negative 2. M square is 1. So m would be square root of 1, which is nothing but plus or minus 1. So what are the roots of this equation? Let me write it down. M is nothing but positive 1, negative 1 and negative 2. So our CF would be, clearly all the three are distinct, right? So we would get A e power x plus B e power negative x plus C e power negative 2x. Okay, so this can be written in any order, right? You can also write negative 1 first, then positive 1, or negative 2 first, a into e to the power negative 2x. The order doesn't matter, only the roots have to be correct. Okay, so moving on, let us solve another question now. Okay, so the question says solve the equation d cube minus 3d square plus 4d minus 2 whole thing into y is equal to 0. Okay, now to solve this equation, try using that inspection method. If we take out d square as common, we will not be able to write it, right? So to solve these kind of equation, we have something called as synthetic division method. Okay, synthetic division method to find the roots of the equation. Now to start with synthetic division, we first have to randomly give values to this equation. Let me write down the auxiliary equation, that is m cube minus 3m square plus 4m minus 2 is equal to 0. Now start giving values. Assume m is equal to 0. Okay, let me assume m is equal to 0. What would we get? 0 minus 3 plus 4 negative 2. So clearly we are getting negative 1, right? This is not equal to 0. Let me take m is equal to 1. We would get 1 minus 3 plus 4 minus 2. 1 minus 3 is negative 2, positive 2. So clearly we are getting 0. So one of the roots of this equation is 1. So using that information, let us apply synthetic division. Write down 1 over here. Write down all of the coefficients, right? Coefficient of m cube is 1. Coefficient of m square is negative 3, 4 and negative 2. Write down a 0 over here, right? And okay. Yes, so let us just solve this. The first step says the synthetic division. Just add these two. 1 plus 0 is 1. Multiply. 1 ones are, we will write it as 1. Again add these two. Negative 3 plus 1 is negative 2. Again 1 into negative 2. Write it over here. That is negative 2. 4 minus 2 is positive 2. Again 1 into positive 2. We would get it as positive 2 itself. 2 minus 2 is 0. Always remember this term what you have over here, the last term should always be 0 in synthetic division. If not, this term whatever you have taken, that is not correct. You will have to change it. Okay. So what is the next step of synthetic division? Just write this. Decrease the order by 1. We would get m square minus 2m. These are the coefficients. Plus 2 is equal to 0. Now again solve this quadratic equation. Let us use the formula m is equal to minus b. In place of b we have negative 2. C is positive 2, right? So you would get positive 2 plus or minus square root of b square, that is 4, minus 4 into a into c, that is 2, divided by 2a. What happens over here? M is nothing but 2 plus or minus square root of 4 minus 8 by 2. So clearly we are getting a negative sign, right? Square root of negative 4 by 2. Yes. So I can write it as negative minus 1 square root of negative 1 into square root of 4. What is square root of 4? We know that it is 2, right? 2 plus or minus 2i divided by 2. Yes. So if we take out 2 is common over here, we would get 1 plus or minus I divided by 2. 2 gets cancelled. We would get 1 plus or minus I. So what are the roots of the equation? The first one, right? The first step we had got m as 1. Here we have m plus or minus I. For a cubic equation, we've got 3 roots, that is 1, 1 plus I and 1 minus I. Okay, so what would the CF be over here? CF is nothing but, y is nothing but C1 e to the power x, because that is a real root, plus this is in the form of a plus or minus I into b, right? Where the value of a is 1 and the value of b is 1 again, because 1 into I is I. So I can write it as e to the power x, 1 into x is x itself, into c1 cos x plus c2 sin x. Okay. Now let us move on to our next question. Say for example we have solve d square minus 9 is equal to 0. Yes, the auxiliary equation, okay, whole thing into y, right? Whole thing into y is equal to 0. They can also give it as z. Okay, you just write the final solution. CF is nothing but z is equal to. Yes, so here let me write the auxiliary equation, which is nothing but m square minus 9 is equal to 0. M square is equal to 9. M is nothing but square root of 9. Clearly we would be getting it as plus or minus 3, right? Because square root of 9 is nothing but 3. So our CF would be y is equal to C1 e to the power 3x plus C2 e to the power negative 3x. Okay. So yes, let us solve another question. Say for example we have solve d square minus 5d plus 7 whole thing into y is nothing but 0. So clearly the auxiliary equation over here would be m square minus 5m plus 7 is equal to 0. I know that 7 table, in 7 table 7 ones are 7. 7 is a prime number, so we only get 7 into 7. 7 plus 1 is 8, 7 minus 1 is 6. So let me use the formula, that is m is equal to, in place of a I have 1, place of b I have negative 5, c is 7. Right? So I would be getting minus b, that is positive 5 plus or minus square root of b square 25 minus 4 into 1 into 7. 28, right? Divided by 2. Yes, so I would be getting 5 plus or minus square root of 25 minus 28, which is nothing but negative 3 by 2. Yes, I can again write this as 5 plus or minus negative square root of 3 into I divided by 2, or I can also write it as 5 by 2 plus or minus square root of 3 by 2 into I. Now clearly I can say, right, in place of A I have 5 by 2, in place of B I have root 3 by 2. It is simple to write the CF. Agree? Our CF would become e to the power ax. Agree? E to the power 5 by 2x. Yes? Into C1 cos bx, that is root 3 by 2x plus C2 sin root 3 by 2 into x. Okay, even here the constants doesn't matter. You can also write C1 sin root 3 2 by x plus b cos root 3 2 by x. These are just constants. Okay. Now say for example we have another question that says, the 11th one, that says solve d square y by dx square plus a square into y is equal to 0. If I write it like this, replace that, d square by dx square as d square, I would get something like this, that is d square plus a square whole thing into y is equal to 0. What would our auxiliary equation be? It would be m square plus a square is nothing but 0. Agree? Send it to the other side. M square is nothing but minus a square on transposing. Agree? So m is what? M is nothing but square root of negative a square, or you also write it as negative 1 into square root of a square. So we get plus or minus a into I. Right? So what would our final answer be? It would be e to the power 0 into x into a cos ax plus b sin a into x. This is our final solution for the given differential equation. You can also just leave that e to the power 0x and write it as a cos ax plus b sin ax. Okay, let us solve one last question that says, yes, so the 12th one, right? Let us solve one last question that says, 12th one, solve 2d square plus 7d plus 5 whole thing into y is nothing but 0. Yes, so how do we solve this equation? Clearly, let me write the auxiliary equation. Replace d with m, we get 2m square plus 7m plus 5 is equal to 0. We have 5 2s are 10, and clearly 5 plus 2 is 7, right? So as simple as that, 2m square plus 2m plus 5m. I'm splitting the middle term basically. So I would get 2m into m plus 1 plus 5 into m plus 1. Agree? This is nothing but 0. Yes? So what happens to our m values? We would be left with 2m plus 5 into m plus 1 is nothing but 0. So 2m plus 5 equating each term to 0 we would get the values as m is nothing but transpose 5 to the other side, you would get -5. 2 is in multiplication, right? When transposed, it becomes division. Over here, m is nothing but -1. So our final answer, the CF, would be e to the power -5 by 2x. Right? Let me write down a constant over here. Plus b into e to the power -x. So yes, these are the three ways, right? So these three cases are really important. Please make a note of it before solving the problems. Right? It would be really helpful. Which were the three ones? Yes, over here. Three cases, right? So if m1 and m2 are real and distinct, what would be the CF? If they are real and equal, what would be the CF? And if they are imaginary, what would be the CF? Yes, so in our next session, let us try solving non-homogeneous differential equations, which is where our particular integral comes into picture. Okay, thank you.